So hello everyone, today we are going to start measurement of physical quantities. Okay, so first let's see what do you mean by a physical quantity. Now quantity quantity are of two types. One is physical quantity and the other is non-physical. Okay, now what do you mean by physical quantities? In this chapter we are going to study physical quantities and its measurement. Physical quantities are those quantities physical quantities are those quantities that can be measured that can be measured. Okay, so measurement means you can represent it with a magnitude or a number. Suppose your weight or your mass, these are physical quantities. You can represent it with a number. Suppose your weight is 50 kg, suppose, for example. So 50 is the number by which we can express your weight. Okay, you can represent your weight. And on the other hand, non-physical quantities are those which cannot be measured. Those quantities which cannot be measured. Here physical quantities, what can be the probable examples? Suppose your weight. Okay, suppose your weight, then your height, you can measure your height. Okay, then your suppose volume. Okay, then area. Okay, so these are physical quantities. And also suppose density. So these are physical quantities. There are many more. The list is very long. There are many more. And non-physical quantities are those quantities which we cannot measure, which cannot be measured. So examples of these quantities are, suppose today you are sad. Today you are not feeling good. You are sad. Okay. So how much sad you are? Okay. It's an emotion. It's a feeling. You know that you are sad. But if someone asks you that how much you are sad, can you represent it with a number? No. So feelings, whatever feelings you have, these are non-physical quantities. Example, sadness, then any sort of emotions, any sort of emotions. Suppose let me write it in this way: emotions or feelings like sadness or happiness. Emotions or feelings like sadness or happiness. Okay, like sadness or happiness. Now in this chapter we are going to study some of the physical quantities and we will also learn how to measure them. So let's see what are the physical quantities we are going to study in this chapter. First thing, we are going to start with this density. So let's see what is density. Now density is the mass of an object per unit volume. See, what does it mean? First let me write. Density, from now on in further higher classes, density will be represented by a Greek letter is rho. It is not like P. It is this portion is slanting. It is like this. Okay. It is not this. This is P, and this is rho. This is letter P. This is English letter. This is English letter. Okay. Then P, and this is RHO, rho. From now on, density will be represented by the symbol RHO, and its symbol is like this. This is slanting. This is straight. This is slanting. Okay. So density is mass of an object per unit volume. Mass of an object per unit volume. So it can be represented as the density rho is equals to m for mass by volume. This is m for mass and this is volume. Okay. Now there are where is this mass coming from? Where is this mass coming from? Now see, density means mass per unit volume. So suppose first let us see what are the units Okay, what are the units? Now we know there are two systems of units which are common to us. One is there are many more, but in our academics we need mainly two types of systems, that is SI, most important, that is Standard International, and CGS. Okay, so first is SI unit and the other one is CGS. Okay, now from the name we can see that L will be represented in CGS system, length L represented by centimeter. See, this is C for centimeter. Next one is mass, LMT. Okay, always remember LMT, length, mass, time. Okay, first one is for length, then the second one is for mass, and the third one is for time. M is represented in G for gram, CG, and time is represented by S for second. Okay, S for second. Time is represented by second in almost all systems. Okay, now let us take a look at the SI system, by SI unit. Here L is represented by meter. There is centimeter in CGS and here it is meter. M is represented by, mass is represented by kilogram. Okay, and time, just like here also, it is represented by seconds. It is measured by seconds. Okay, now density is mass per unit volume. It means it is the amount of mass that is present in a unit volume of a substance. Means, suppose there is a tank like this, a box. Suppose there is a box like this. There is a box like this, and the amount of matter that is present in the box. Now the dimension of the box, let us say this is 1 meter. This is also 1 meter. And its height is also 1 meter. So we can see that it is a cube. Cube has length, breadth and height all same. Okay, see, length also 1 meter, breadth also 1 meter, height also 1 meter. Okay, so it's a cube. And cuboid means length, breadth and height are different. Cuboid also looks like a box, but its dimensions are different. It can be rectangular in shape. So now its volume will be how much? Volume will be length into breadth into height, means 1 meter into 1 meter into 1 meter. Okay, so it will come out to be 1 meter cube. 1 meter cube. Okay, now your body contains lot of molecules. Okay, and the molecules has mass, molecules or atoms. Your body contains molecules and atoms, and each atom has mass. From where the mass is coming? See, in periodic table any element can be represented by in this form. Here we have A and here we have Z. Any element in the chemistry, I am talking about chemistry, periodic table, any element can be represented in this way, where this A is the mass number and this A is the mass number, and this Z is the atomic number. Okay, this Z is the atomic number. Now atomic number means the number of, what are the subatomic particles present in an atom? An atom is made up of neutron, proton and electron. Now electrons are considered massless, means they have mass but their mass is neglected, their mass is not calculated, considered to be zero. Their mass is considered to be zero because they are very much smaller in comparison to proton and neutron. Okay, and proton and neutron, where they are present? They are present inside the nucleus, and surrounding it revolves in their orbits what? Electrons. So these electrons are considered massless. For a total atom, only mass of the nucleus, means mass of the protons and neutrons present inside the nucleus, is considered. Okay, now atomic number means number of protons, okay, number of protons, and mass number means number of protons plus neutrons. Mass number means number of protons plus neutrons. Total number of protons and neutrons. Number of protons plus number of neutrons. Okay, so it will be P plus N. Proton plus neutron, and atomic number is only proton. So you can see that mass number should always be greater than atomic number. Okay. Now you should remember one thing, that sometimes it becomes confusing that by the letter A, generally what we see that it can represent atomic number, because atomic number also starts with A, isn't it? Atomic number also starts with A, so A for atomic number. Now here is the confusion. Scientists have represented in this way only. I don't know whether there is any logic or not. It may be illogical, but still you have to remember in this way that it's just the opposite. By A, mass number is represented, not the atomic number. Okay, you need to remember this, don't get confused. Okay, now mass number, from this mass number we can have an idea of how heavy a particular atom is. What is the mass of a particular atom? Now see, I am taking an example of oxygen, where it is, let me write it over here, oxygen is O, represented by the symbol O. Here X, I am writing O. X is unknown, X is random. In any element I am represented by X, but for a particular element, suppose oxygen, the mass number is 16 and the atomic number is 8. Now for finding the mass of oxygen, we don't need atomic number, we only need mass number. Okay, we don't need atomic number, we only need mass number. So 16 gram, therefore 16 gram, it is represented in gram, is the mass of one atom of oxygen. Now actually this 16 gram is not the mass of one atom of oxygen, it is actually the mass of a huge number of atoms of oxygen, that is 6.023 into 10 to the power 23 number of oxygens. Total mass is 16 gram, but for timing, since you are in class 8, for the timing, just to make it simple, you just assume that 16 gram is the mass of one atom of oxygen. Now oxygen, you know, gaseous oxygen is oxygen molecule. So oxygen molecule is what? O2. Oxygen molecule is O2, right? Now O2 has how many O? O plus O, there are 2 O. So what will be the total mass of the oxygen molecule? It will be a single atom 16 plus another single atom 16, so it will be 32 gram. And 32 gram is the mass of, see, 16 gram is the mass of one atom of oxygen, and 32 gram is the mass of one molecule of oxygen. It is mass of one atom, here it is the mass of one molecule. Okay, is the mass of one molecule of oxygen. Got it? Let me write this over here. Oh, 16, 8, we only need the atomic number. I'm sorry, we only need the mass number. Okay, so it is clear. Now this box may contain huge number of oxygen. Suppose there are 10,000, or suppose there are 1 lakh oxygen molecules present. Okay. Now we know one molecule mass is 32 gram. One molecule mass of one molecule of oxygen. Suppose in this box there are, suppose in this box, this box is filled with, suppose this box is filled with 1 crore molecules of oxygen. 1 crore molecules of oxygen. So mass of each molecule is 32 gram. So what will be the total mass present inside this box? Total mass present will be total mass will be equal to 1 crore multiplied by 32 gram. Okay, each oxygen molecule is 32 gram, and there are 1 crore of such molecules present inside this box. So what is the total mass of oxygen molecules, oxygen present inside this box, is 1 crore multiplied by 32. It is simple unitary method. Okay, got it? Now this 1 crore into 32, whatever we get, this is the M. So this is done, we have found out this. Okay, this is the mass, and volume is this is V for volume. So 32 crore means 32 gram into 1 crore means 32 crore gram. Okay, is the mass, and volume is 1 meter cube. So the density will be mass per unit volume, and that is expressed, suppose mass is expressed in gram, so if we convert it in kg, okay, it will be something kg. Suppose it is expressed in kg, and volume will be expressed in meter cube. Okay, now this becomes what? This becomes kg per meter cube. Mass is expressed in kg, volume in meter cube, kg per meter cube, and this is SI system. This is SI. Okay, the same thing if you are going to express it in CGS, then it will be what? The mass will be in gram, okay, and the volume will be in centimeter cube, because you know that CGS system, length is measured in centimeter, so volume will be measured in centimeter cube, area will be measured in centimeter square, okay. So here also in SI system also, if the length is measured in meter, the area will be measured in meter square and the volume will be measured in meter cube. So it will be what? It will be gram per centimeter cube, okay. This is CGS, this is SI, okay, this is SI, CGS, CGS, and this is also CGS, okay, also CGS. So you pause the video and note all these things, okay, then I will wrap the board. You pause the video, pause the video and note these things. Then we are going to our next topic, that is measurement of density, how to measure it, okay. So density, we have discussed that it is how tightly a particular box of unit volume means one, a particular box of unit volume is packed with molecules. In solids, this packing is very tightly packed. In liquids, the packing is less tight than solids, and in gases they are loosely packed, means in a box of 1 meter cube only few molecules of gas will be present. Liquids will be more in volume than gases, and solids are very tightly packed, so there will be much more number of molecules of solids present, okay. That's why the density of solids is higher. The volume remains same, V is same. Now if this M increases on a fixed volume, then the fraction also, total fraction also increases, isn't it? If the numerator increases, numerator is constant, fixed, then the density increases, because it is, suppose this is 2, volume is 2 and this mass is suppose 4 by 2, it will be, answer is 2, divided by 2, answer is 2. Now it is 2 fixed, next the mass becomes 6, then what will be the answer? 6 by 2, answer will be 3. Now again the volume is fixed 2, it becomes 10, then what will be the answer? 10 by 2, we cut it, it will be answer 5. So answer means density. So this increases if the mass increases and the volume is fixed, okay. So solids have highest density, less than that is liquid, and less than that is gases, okay. So I'm rubbing the board. Now let's come to the measurement of density. Previously we discussed the what is actually density, about the quantity. Now how to measure it? We are going for measurement of density. Measurement of density. First we take measurement of density of solids, then we will come to measurement of density of liquids. Now as we know that density is equals to M by V. To measure M is simple. Mass is measured by what? An apparatus which is known as physical balance, or beam balance. Physical balance or beam balance, it will give you the value of mass in kilogram or in gram, okay. That is very simple. You put the object on the machine, it will give you the value, okay. If it is digital, it will directly give you the value. And if it is suppose beam balance, means you have to there is a, you know, in vendors, some of them, the old ones have a machine, an apparatus where they put weights on both sides and they measure. That's a physical balance, okay, or beam balance. Nowadays it is measured in digital machines, digital weighing machines, okay. Now the main problem lies in calculating volume, okay. The main problem lies in calculating volume, okay. Now see, solids are of two types. Solids are of two types. One is regular and the other one is irregular, okay. Regular and irregular. Now what do you mean by regular solids and irregular solids? Regular solids has fixed dimension, suppose length, breadth, height, radius, okay. Regular solids have fixed solids have fixed dimension. So their volume can be measured by using formula. So their volume can be measured by using formulas. So the volume can be measured by using formulas. For example of regular solids, cube. See, cube has fixed dimensions, means length, breadth and height. If someone provides you length, breadth and height, or if there is a particular cube, you can use your scale and measure the length, you can use your scale, then measure the height, then measure the width, and you multiply length into breadth into height, you get what? Volume. So cube is a regular solid. Then comes cuboid. Okay, another example is cylinder. Then is sphere. Okay, so these volumes you can calculate using formulas. Although in mathematics you only have cube and cuboid in class 8, cylinder and sphere maybe it is there in class 9 or in later. Now what about irregular solids? Irregular solids do not have fixed dimensions. They do not have fixed dimensions. Do not have fixed dimensions. Therefore, their volume cannot be measured by using formula. Volume cannot be measured because they don't have a fixed dimension. They don't have a particular length or breadth or height or radius. Suppose this is an irregular solid. See this. This is an irregular solid. Can you find any length? Can you find any volume? Can you find any breadth? Any radius? Nothing. It's irregular in shape. Okay. So these kind of objects, to find their volume, the only method you can do is by water dipping method. You dip it in water, water will be displaced, and you measure the amount of water displaced. So by that way we can measure its volume. So do not have fixed volume. So volume cannot be measured by using formula. Their volume is measured. Volume is measured by water dipping method. So the volume can be measured by water dipping method. Okay, volume is measured by water dipping method. Now let me make you clear that regular bodies have fixed dimensions, so their volume can be measured by using formula. It's true, but their volume can also be measured by water dipping method. Here you don't have any option. Irregular bodies, you have no option other than using the water dipping method. Now for regular bodies, you have both the options. You can use it, you can find it by, measure their volume by water dipping method also. You can measure their volume by using formulas also. Okay, length into breadth into height, like that thing. Okay. Now let us see how to find the volume of both regular and irregular bodies by water dipping method. Okay. Now see, water dipping method are also of two types. Two types means there are two things that are there in the syllabus. Water dipping methods. First thing that you have is by measuring cylinder. By measuring cylinder, and you need definitely you need water for that measuring cylinder. And the second thing is, means you directly put the object in the measuring cylinder. Okay, and you see the level of water by only measuring cylinder. Okay, and the second way you can find is by using a Eureka can. E-U-R-E-K-A, Eureka, like the spelling. See the spelling. E-U-R-E-K-A, by using a Eureka can and a measuring cylinder along with a measuring cylinder. Okay, here only measuring cylinder is used, and here a Eureka can is used along with the measuring cylinder. So see the two methods. Here while you are using only the measuring cylinder, now the water, this measuring cylinder has markings. Okay, measuring cylinder has markings like this. Okay, now you tie the irregular solid or a regular solid, you tie this solid with a thread or string. Now one thing I forgot to mention is that water dipping method, there is a criteria or condition. Water dipping method, there is a criteria or condition. What is that? Water, or suppose there is oil, you can you do the experiment with oil also, but any liquid you can do. But one thing you must confirm that the solid which we are going to dip inside a particular liquid, maybe water, that solid must be insoluble in that liquid. Means the solid must not dissolve in that liquid. If it dissolves, then when you dip it, it gets mixed with the, it gets dissolved in the liquid only, and when you pick it up, it is vanish. Okay, so water dipping method, here you have to keep it in mind that the solid must be insoluble in the liquid. The solid must be insoluble in the liquid. Okay, so it must be, is the main criteria. You have to ensure it. Okay, the solid must be insoluble in the liquid. If the liquid is water, then whatever solid you are putting inside water must be insoluble in water. Okay, clear? Now, how to measure it? You tie the solid with a thread and you dip the solid. This is a thread. Okay, you are holding it here. Now, before dipping it, you mark the initial level. Suppose it is V1. Now, when you dip it, the level of the water will rise here. Okay, the level of the water will, it is the initial level of the water will rise here. You mark it V2. Now, this portion, this much of volume, okay, this is the volume of the solid. The amount, the level of rise of water, there is nothing but the volume of the the solid that you have dipped. Suppose this portion is V2 minus V1. Okay, the markings are here, starts with 0 from here. Suppose this is 20, this is 30. So in that way, suppose this is 40 and this is 60. Suppose V1 is 40 and V2 is suppose 60. Then V2 minus V1 is this portion. It will be what? 60 minus 40 equal to 20. And if these graduations or markings are in ml, means if this is 40 ml, this is 60 ml, then it will be 40 minus 60 minus 40, this portion, only this portion. Okay, this is the volume. Okay, this will be 20 ml, means the volume of this solid will be 20 ml. Okay, now there is something important concept here. Volume of solids is measured in centimeter cube if it is CGS system, or meter cube if it is SI system. But the volume of fluids, okay, volume of fluids, fluid means what? Fluid means gas and liquid, gas and liquids. Okay, fluids means gases and liquids. Now, volume of fluids are measured in ml or liter. Okay, ml or liter. Liter is the bigger unit, means 1 liter is equals to 1000 milliliter. Ml means milliliter. Oh, okay. So it is measured in ml or liter. These are not SI units. These are not SI units. Okay, don't remember it like that. No, neither these are CGS units. These are units in which volume of liquids are measured. Liquids means liquids and gases are measured. Okay. Now here we are finding the volume of this solid, but from here we found out it is 20 ml. But how can we relate it with the volume of a solid? Because in ml we are getting the volume of the liquid, but here we are supposed to find the volume of the solid. So how to connect it? Now it is observed, you have to remember these two things. First, write it down, pause the video, write it down. I will explain you something here. 20 ml is equal to 20 centimeter cube. Okay, how it is coming, I will explain. This ml and centimeter cube are basically same. First write it down, I will explain. Okay, see, it is found that in a tank, there is a tank. Okay, this is 1 centimeter, this is also 1 centimeter, 1 centimeter. So its volume will be what? 1 into 1 into 1, when it means centimeter, 1 centimeter into 1 centimeter into 1 centimeter, length, breadth, height, it will be 1 centimeter cube. See, centimeter cube can also be written as cc. This is cubic centimeter. Okay, cubic centimeter. Okay, so C for cubic and another C for C. So it can also be written as cc, 1 cc. Okay, 1 centimeter cube means 1 cc. Short form, say abbreviation, cubic centimeter. Now if we fill this tank with any liquid, fill it with any liquid, okay, any liquid, it may not be water, any liquid, it is found that when you fill the entire tank of 1 centimeter cube dimension, 1 centimeter, 1 centimeter, 1 centimeter dimension, then 1 ml will fill the entire tank. ml will fill this full tank. 1 ml of any liquid will fill this full tank. So from here we concluded that 1 centimeter cube is equal to 1 ml, okay, milliliter. ml means milliliter, it's millimeter, so milliliter, okay, smaller unit of liter, milliliter. Similarly, now this centimeter cube is SI, okay, sorry, this is CGS, C for centimeter, okay. So volume, if you measure in CGS system, it is centimeter cube. Now in SI system, what will be the volume? It is meter cube. So there is another relation where a bigger tank is taken, okay, a bigger tank is taken whose dimensions are 1 meter, 1 meter, 1 meter, and if you fill this tank with any liquid, if you fill this bigger tank whose dimensions are 1 meter, 1 meter, 1 meter, so how much will its volume? Its volume will be 1 meter into 1 meter into 1 meter, its volume will be 1 meter cube, okay. So if you fill it with any liquid, if you fill it with any liquid, its volume will be, it is found out that 1000 liters of any liquid is required to fill the tank full. 1000 liter of any liquid is required to fill the tank full. Means a tank of 1 meter cube volume, 1 meter, 1 meter, 1 meter, 1 meter cube volume can be filled by 1000 liter of any liquid. So from here we draw the conclusion that 1 meter cube is equals to 1000 liter. 1 meter cube equal to 1000 liter. Now since centimeter cube is CGS unit, this meter cube is SI, okay. The relation between SI unit of volume to the liter or milliliter volume of liquid. This side is volume of solid to liquid connection, okay, solid to liquid connection. Here also this side is solid and this side is liquid, okay. This side is solid, this side is liquid. The connection between solid volume and liquid volume, okay. This connection is required. Why? You know, because in water dipping method you see that we get the volume in terms of liquid volume, so you have to convert it to solid volume. So these relations are required, okay. These two relations, 1 centimeter cube equal to 1 ml and 1 meter cube equal to 1000 liter, okay. So remember, okay. Now let's see how we can establish. Let's see. Now this can also be proved, that 1 meter cube, if 1 meter cube equal to 1000 liter, from here we can get 1 meter cube equal to 1 ml. You see how I am proving it, you see. Now 1 meter cube equal to 1000 liter, okay. Now see, 1 meter cube equal to how many centimeter cube? 1 meter equal to how much centimeter? 100 centimeter, you know. 1 meter equal to 100 centimeter, because after meter, after two places we get centimeter, then another one place we get millimeter. So 1 meter equal to 100 centimeter, and here 1 liter equal to 1000 milliliter. Here there is 1000 liter, so 1 liter equal to 1000 milliliter. So 1000 liter will be what? 1000 into 1000 milliliter, that is 10 to the power what? 1, 2, 3, 4, 5, 6, 10 to the power 6 ml. Okay, so 1000 liter is nothing but 1 to 10 to the power 6, 10 to the power 6 ml. Okay. Now what about 1 meter cube? 1 meter cube means 1 meter into 1 meter into 1 meter. You agree or not? Now we are converting each meter into centimeter. So 1 meter equal to what? 100 centimeter multiplied by another 100 centimeter multiplied by another 100 centimeter. Okay. 1 meter cube means 1 meter into 1 meter into 1 meter. So this 1 meter is 100 centimeter into another 100 centimeter into another 100 centimeter. So total will be how much? 10 to the power 1, 2, 3, 4, 5, 6. 6, and this is centimeter cube. Okay. See, 1 meter cube is 10 to the power 6 centimeter cube. 1 meter cube is 10 to the power 6 centimeter cube, and 1000 liter is 10 to the power 6 ml. Okay, 1000 liter is nothing but 10 to the power 6 milliliter. So we can see that from here what we conclude is that 10 to the power 6 centimeter cube is equals to 10 to the power 6 ml. Okay, so if we cut 10 to the power 6 from both sides, we will get 1 centimeter cube is equals to 1 ml. Okay, okay, if we cut it from both sides, you will see that 1 centimeter cube equal to 1 ml. So proved. Okay, so 1 cc equal to 1 ml. Cc means centimeter cube. Okay, write it down. I will rub the board. Pause the video, write it down. We will see how to find the volume by Eureka can. Another apparatus is there, na? Eureka can. Eureka can is like a kettle which has an opening here, Okay, this is Eureka can. E-U-R-E-K, Eureka can. Now the water is filled up to this level. Now when you insert the solid with a thread, you tie the solid with a thread, same process, tie the solid with a thread and you dip it, what will happen? This will rise, but in measuring cylinder it was rising, here it will not rise. Here the water displaced will fall through this opening. Here the water will fall through this opening. Okay, and this will fill inside a measuring cylinder. Here we will place a measuring cylinder. Okay, water will come and it will fall inside an empty measuring cylinder. This is a measuring cylinder. Now this is empty. Previously this is empty. This is not filled with water. It was completely empty. Whatever water will come, it will start filling up from 0. This is the 0 level, 0 ml. Okay, this is the 0 ml. It will start from 0. But okay, 0 ml. It will start from 0. Suppose it is filled up to here, and you say this is 30 ml. So this is totally 30 ml. 30 ml. 30 ml will be the volume of these solids. Okay, this is the volume of these solids. Here we don't have to minus, subtract it. No. While only using the measuring cylinder, we have to note the initial level. Then after dipping, the water will rise. You will mark the final level. Then you subtract the initial level from the final level. You get the volume of the solids. Here no subtraction is required. Whatever liquid will come from this Eureka can into this measuring cylinder, that much it will start filling from empty, start filling from 0. This 30 ml will be the volume of this solid. Okay, so that's all about Eureka can. Okay, it is nothing so special. Now we found out the density in this way. Okay, suppose now density is evaluated M by V, M from beam balance or physical balance, and V from water dipping. Okay, there are two forms of water dipping. One is Eureka can and another is only measuring cylinder, and another one is Eureka can plus measuring cylinder. Okay, and if you can find it out by formula, if it's a regular solid and it has the dimensions are measurable, then you can find it out by using formula as well. Okay, the volume and mass is only by beam balance. So density is done. Okay, density of solids is done. Now let us see how to measure the density of liquids. Density of liquids can be measured by, number one is density bottle. Okay, and number two is hydrometer. Okay, hydrometer is a advanced apparatus. We just see the reading. I will discuss it later. First we will learn how to find it by density bottle. Okay, what is the density bottle? See, we are doing density of liquids. Okay, solids is done. This is liquids. Density of unknown liquids. We need to know one thing, that density of water is a known liquid. Generally we are talking about density of liquids which are unknown. Unknown liquids. Okay, unknown liquids. Okay, now density of water. Water is a known liquid. Water is a known liquid. It's not an unknown liquid. It's a known liquid. We know the density of water, so it's a known liquid. Density of water is equal to 1 gram per centimeter cube or 1 kg, sorry, 1000 kg per meter cube. 1 gram per centimeter cube, or it is 1000 kg per meter cube. Okay, 1000 kg per meter cube, and both of them are measured at 4 degrees centigrade, at a temperature of 4 degrees centigrade. The density of water is 1 gram per cc or 1000 kg per meter cube only at 4 degrees centigrade. At other temperatures, suppose at 0 degree sorry, at 2 degrees centigrade, 10 degree, 12 degree, the density values will differ. Not very much, but it will differ. Suppose at 30 degrees centigrade, the density value will be maybe 0.9 gram per cc. You don't know. Okay, so at 4 degrees centigrade, its value is 1 gram per cc, and in CGS system and in SI system, it is 1000 kg per meter cube. Now you will see that 1 gram per centimeter cube is equal to 1000 kg per meter cube. See how we are going to derive the relation between CGS unit of density and SI unit of density. See how to derive the relation. See. Let us take 1 gram per cc, okay, which is equal to 1 gram by 1 centimeter cube. Cc means centimeter cube. Okay, this is basically 1 gram per cc, no? 1 gram by 1 cc, that we are writing 1 gram by 1 centimeter cube. Now 1 gram is equal to 1 by 1000 kg. Okay, we know that 1 kg equal to 1000 gram. So if we reverse it, 1 by 1000 kg is equals to 1 gram. Okay, so we see that 1 gram we can write in that place 1 by 1000 kg. Now 1 centimeter cube we can write what? We can write 1 by, now see here, you can see here 1 meter equal to 100 centimeters. So in the same way, 1 by 100 meter is equals to 1 centimeter. Okay, got it? If you bring this 100 down, 1 by 100, it will be equal to 1 centimeter. Fine. So 1 centimeter cube means 1 centimeter into 1 centimeter into 1 centimeter. Okay, 1 centimeter into 1 centimeter into 1 centimeter. So it will be 1 by 100 meter into 1 by 100 meter into 1 by 100 meter. Is it clear? See, is it clear? So it will be what? 1 by 1000 kg divided by 1 by 1, 2, 3, 4, 5, 6 meter cube. Okay, meter cube. See, is okay? Now this is numerator and this is denominator. So if you write 1 by 1000 divided by 1, 2, 3, 4, 5, 6, it will be what? 1 by 1000 into 1, 2, 3, 4, 5, 6. Okay, you cut it. It will be inverse, no? Division converted to multiplication, it will upside down 3. So you get 1000. So we have started with, see, 1 gram per cc, and it is equal to 1000. Here it is kg per meter cube. It is kg per meter cube. So kg per meter cube. Done. So it is proved that 1 gram per cc is equals to 1000 kg per meter cube. Write it down. Write it down. Then I will pause the video, write it down, I will rub the board. Okay. Okay. See, a density bottle is a grounded glass topper. It is a glass bottle with a grounded glass topper. Grounded means it has a glass topper. It's like this. Okay. The bottle is like this. Here you have a glass topper. You have a cap. This is the neck. This is a density bottle. It's just like a reagent bottle in your chemistry lab. Now, how to find the density of liquids by using this bottle? First, we weight this bottle and find the mass of the empty bottle. Suppose we pick it up and we place it on the physical or beam balance, we get the mass of the empty bottle. First the bottle is empty, you just measure the mass of the empty bottle using physical balance or beam balance. So we note it as M1. M1 is mass of only bottle or empty bottle. Only bottle. Only means empty. Only means empty. Dry and empty, so that no liquid is present inside it. Okay. Then we fill the bottle with water. Then we fill the bottle with water and again measure its mass. Fill it with water, full with water. You take it and place it on physical balance or beam balance. You get the mass and you note it as M2, which will be the mass of what? Bottle plus what? Bottle plus water. Bottle plus water. This is only bottle M1, M2 is bottle plus water. Now you pour the water outside. Again it is empty. Now you fill the unknown liquid of whose density you are going to find. Suppose the unknown liquid is milk. You are finding out the density of milk. What we will do? You will put milk in this bottle again, fill it completely. Then you measure the mass of the bottle along with the milk. So and note it as M3. It will be mass of bottle plus liquid. Here I am talking about milk. Liquid means the unknown liquid whose density you are going to find out. Unknown liquid. Okay. Here for example it is milk. For example. Okay. Milk means bottle plus milk. Okay. It can be kerosene oil. It can be any liquid. Okay. Now what to do with these values? See, if we do M2 minus M1, we will get what? M2 minus M1. Now suppose all the masses are measured in gram. M1 is also measured in gram, measured in gram. So M2 minus M1 means mass of bottle plus water minus bottle. So what will be the remaining? M2 is bottle plus water. M1 is only bottle. So if you subtract bottle plus water, if you subtract bottle from bottle plus water, only remaining will be water. So M2 minus M1 will give you what? Mass of water present inside density bottle. Mass of water present inside density bottle, and that will you will also get in form of in gram. Okay. Because these all are measured in gram, so M2 minus M1 is also in gram. Okay, mass of water present inside density bottle. Now, density of water. Now, wait, this is done. Okay, now we are finding out M3 minus M1. Can you tell me what it will give? M3 minus M1. What it will give? What is M3? M3 is bottle plus milk. And M1 is only bottle. So if you minus bottle from bottle plus milk, it will only give you milk. So M3 minus M1 will give you what? Mass of milk present inside density bottle. Mass of milk present inside density bottle. Okay, mass of milk present inside density bottle. Now, to find the density, you get the mass of milk present inside density bottle, and that is nothing but M. Okay, that is nothing but mass of milk is M. To find density, you need density of what? Density of milk. You need to find density of milk. You need mass of milk by volume of milk. Here the volume is fixed, means when I have put water, the volume is same as when I have put milk. Okay, so it's the volume of milk, which is nothing but the volume of bottle itself. Volume of bottle itself. Now how to get it? We have got this. This is volume. Mass of milk is M3 minus M1. How to find the volume of this bottle? Now we see that we have found out M2 minus M1, mass of water present inside density bottle. Now what we will do with it? Because mass of water is not required. mass of milk is required and the volume of the water is required. So what are we going to do with the mass of water? Isn't it? Question must arise in your head, in your mind. You must ask yourself that mass of water is not required. You need mass of milk, you have found out. So what we will do with the mass of water now? Mass of water is required to find the volume of the bottle. See how. So you see one thing, density of water is 1 gram per cc, right? Density of water is density of water is 1 gram per cc, 1 gram per centimeter cube. What does that mean? It means 1 gram water has volume 1 cc. 1 gram water has volume 1 cc. Okay, 1 gram per cc means 1 gram in 1 cc. If there is a box of 1 cc, there will be 1 gram of water molecules present inside it. So 1 gram of water occupies space. Volume means how much space a particular thing is occupying. So 1 gram of water will occupy a space of, means has a volume of 1 cc. So m2 minus m1 is the mass of water. So m2 minus m1 gram of water will occupy, if 1 gram of water has volume of 1 cc, m2 minus m1 gram of water will have how much? m2 minus m1 cc. m2 minus m1 cc. Okay, 1 gram 1 cc, 2 gram 2 cc, 3 gram 3 cc, m2 minus m1 gram, m2 minus m1 cc. Simple. So volume of the bottle is the volume of water. Okay, same bottle you are filling with water. So this volume of bottle is equal to volume of water, and it is equal to m2 minus m1. Okay, m2 minus m1. So density is equals to numerator m3 minus m1 by m2 minus m1. Okay, so this is in cc. Okay, now density of water is expressed in 1 gram per cc. You can also write it 1 gram per ml, because you know cc and ml are equal. 1 cc equal to 1 ml. So 1 gram per cc or 1 gram per ml is writing same thing. Okay, 2 gram per cc, 2 gram per ml, 3 gram per cc, 3 gram per ml, same. Okay, so write it down. This is the, in this way you can find out the density of an unknown liquid by using density bottle. Okay, it may look like as if the numerator is also mass, denominator is also mass, but this denominator, this is volume actually. Numerically it is m2 minus m1, but if you write it, this is m2 minus m1, then only the numerical value. The unit is cc. Okay, but here the unit should be that of the mass. Okay, numerator mass, denominator it will be cc, that is volume. Okay, see, gram is not becoming cc, the numbers are same, 1 gram 1 cc. So m2 minus m1 gram, m2 minus m1 cc, these are just the numbers. M2 and m1 is just the numbers. Okay, so write it down, pause the video, write it down. This is density bottle, this is density bottle. Okay, now what is hydrometer? The second method of finding out the density of liquid by using hydrometer. Hydrometer is a device. Suppose you take a can, you have a liquid, it's a device. This is hydrometer, where you have mercury filled here. It is used to make it heavier so that it floats. This hydrometer floats in the liquid on which you place it. Now this hydrometer is marked, okay, graduated in such a way. Here the markings are that of density values only. Markings are density values. It's not volume. It's not like measuring cylinder. In measuring cylinder, the markings are in ml, but here directly the density values are marked. So it will float on this liquid. Now if it floats in this way, suppose if it floats in this way, this will give you higher value of density. If the density of liquid is higher, very heavy liquid, thick liquid, denser liquid, then the hydrometer will not come down, it will float higher. Now if the density of the liquid is very less, thin liquid, then it will submerge by a greater portion, and the markings of this hydrometer is in the reverse direction. Higher value here, it is, suppose it is 2 gram per cc, here it will be 1 gram per cc, and here it will be even smaller, suppose 0 gram per cc, or 0 maybe it is, okay, it is 0.2 gram per cc. It means if the liquid has very less density, it will submerge by a greater portion. Okay, suppose this is 1, this is 1 for this hydrometer, and there is another hydrometer where this is suppose 0.2. okay, if the liquid is very thin, it will be 0.2. If it is water, then this hydrometer will be the correct picture, and if it is any thicker liquid, it will be like this. Okay, because we will study flotation and we will see if the density of liquid is high, thicker liquid, denser liquid, then the body will rise. If it is a thinner liquid, less denser liquid, it will submerge, sink not totally but to a greater volume. Okay, so this is the concept of hydrometer. Here markings are directly in gram per cc, which is directly they will give you density. You don't need to measure mass here, you don't need to measure volume here, just put it here, it will give you directly the value of density. Okay, density of milk, to check the purity of milk, we use lactometer, which is nothing but a special type of hydrometer. The special type of hydrometer is lactometer. Special types of hydrometer are lactometer. Okay, to measure the purity of milk, what it is done, what is it is used to measure the purity of milk. And another one is lead acid hydrometer. Lead acid hydrometer, it is used to check the car battery. Car means automobile. Okay, car battery is charged or not. Check the automobile battery is charged or not. Is charged or not. It's not only automobile, any battery is charged or not. Okay, let's rub the automobile here to check the battery is charged or not. You are using lead acid hydrometer. Okay, so hydrometer give you directly the value of density. Now